Generating your own power means you get to watch your utility meter slow down, stop, and actually spin backward. This diagram shows the exact wiring path we need to build. We are going to map out the physical connections required to safely route electricity from rooftop solar panels all the way down into your home's main electrical panel. Before we trace the wires, ensure the physical heavy lifting is complete. Your solar panels, the inverter, and the distribution boxes must already be securely mounted to your roof and walls. You also need to verify that all main grid power is completely switched off. Use proper lockout and tagout procedures. Do not touch a single wire until the system is dead. Having your hardware secured in place and the grid totally isolated turns a highly dangerous electrical project into a predictable, step-by-step process. We start on the roof. Solar modules produce direct current, or DC, electricity. By snapping their NC4 connectors together in a series loop, you combine their individual outputs to reach the voltage your inverter requires. Once your array is linked, you test the total output with a multimeter. At this stage, strict polarity is required. The red cables carry the positive charge, and the black cables carry the negative. You then route those red and black cables down from the roof array and connect them directly into the input terminals of the DC distribution box, or DC-DB. You cannot use standard household breakers inside this box. DC electricity flows constantly and can sustain a massive electrical arc if interrupted improperly. Specialized DC breakers are required to safely cut this current. The DC distribution box acts as your first line of defense. It safely manages the raw, high-voltage energy before it reaches your other equipment. From the bottom of the DC distribution box, you continue the circuit by routing the red and black lines into the MC4 connectors at the base of your grid tie inverter. This inverter performs the heavy lifting. It takes the raw, direct current from the panels and transforms it into alternating current, or AC, which is the exact type of electricity your home appliances use. Notice the wiring leaving the right side of the inverter in this diagram. It shows red, yellow, and blue wires, indicating a complex three-phase electrical system. Most homes operate on a standard single-phase system. You adapt this layout by eliminating the extra phases, leaving you with just two main lines, one live wire and one neutral wire. Identifying the phase requirements of your specific panel ensures that the inverter's output cables are landed on the correct busbars. This step establishes the electrical compatibility required for the solar system to synchronize with the utility grid. With power converted, you route the live and neutral AC wires out of the inverter and into the AC distribution box. Finally, these output lines are wired directly into a properly sized breaker inside your home's main distribution panel. The electricity now has a path to flow, but the installation is missing a critical life safety feature, the earthing network. Look at the green wiring in the diagram. A continuous copper grounding wire must physically bolt to the metal frames of the solar modules, run through the DC box, the inverter, the AC box, and tie directly into the earth. If a wire frays or a component fails, this green path channels the rogue electricity safely into the ground. Without it, the metal frames of your solar array become an active, lethal shock hazard. Let's review the completed circuit. Direct current flows from the roof panels through the DC protection box into the inverter for AC conversion, out through the AC protection box, and finally into your home's main panel. At this point, the physical wiring phase of your project is officially complete. Before you can flip the switches, your local utility and city inspectors must evaluate the work. Passing this inspection earns your official permission to operate. Once you have that approval, you can activate the breakers. The system will sync with the grid, and your home will start drawing its energy straight from the sun. Following this wiring roadmap results in a safe, code-compliant connection that allows you to consistently offset your utility consumption with self-generated power.